This is Professor Pelton. This is Algebra 2, Chapter 6, Section 6. This is Part 3 of the video. So we're solving log equations. So we're on page 5. Okay, so if you remember real quick, do a little bit of review. There are many equation variations for the exponential equation. Okay, so the standard exponential equation, whoops, y equals a times b to the x, and we did a interest rate one, or anything that involves percentages. It ended up being a times 1 plus r to the t. So we modified that b to include interest rate. Then we had, so if you have compounds, we did a equals p to the 1 plus r over n to the nt, which is the formula where we include compounds. So compounded monthly, daily, stuff like that. And the final one is if it was compounding continuously, it's p times e to the rt. So all of your word problems generally revolve around one of these four formulas. Typically, we're going to be doing the latter three because they're mostly involving percentages. Determine how long it will take $25,000 to grow to $500,000 if the account pays 9% annual interest compounded monthly. Since we have compounds monthly, it's this one. If it was no compounds, it'd be the one before it. If it's continuously, it'd be the one below it. So our original amount, the final amount we want is $500,000. That's our A. The principal amount is $25,000, and it's 1 plus the rate, which is 9% over 12 for the months for the compounds, and then 12 times t. Okay, because we don't know how many years this is going to take. So basic solving technique: divide by 25,000, divide by 25,000, cancels, leaves you with 20 equals 1 plus 0.09 over 12 to the 12t. So you need to get that t down. So this is where we have to use logs. You can use any log you want. It doesn't really matter. I'm going to use natural log, so it's less to write. Natural log of 1 plus 0.09 to the 12t. Now I can use the power rule to bring that down. So I have the natural log of 20 equals 12t times the natural log. Okay. So now I have the t by itself, so I can divide by 12 times the natural log of 1 plus 0.09 over 12. 12 times the natural log of 1 plus 0.09 over 12. Okay, so cancel, cancel. T is approximately, and you're going to get 33.41 years. Okay, so it takes a long time. You're almost never going to get perfect answers on these and work out to nice whole numbers. It's not going to happen. Make sure you label all answers, and the order you put these in the calculator is very important too. Okay. All right, student problem. Pause the video. Try for yourself. Okay, so we're compounding weekly this time. So we're going to lose money. So we're going to shrink down to $10,000. Our original principal was $25,000. Our interest rate is losing 5%, and it's weekly, so it's 52. It's our compounds. So we'll divide by the 25,000. So that's 2/5, right? Because those cancel, gives me 10/25. So that's 1 plus negative 0.05 over 52 to the 52t. So I need to get that down there, so I need to use some kind of log. I like to use natural log. You can usually use any log you want. So the natural log of that stuff. Okay, so my power will come down now. So I have the natural log of 2/5 equals 52. Ah, that 5 got a RAR there. (52t) times the natural log of 1 plus the loss of 5% over 52. Okay, so now I can divide by those constant amounts, because you can divide by constants, right? Okay, so essentially cancels. T equals the natural log of 2/5 divided by 52 times the natural log of 1 minus 0.05 over 52. Okay, so T is approximately 18.32 years. Okay, what's important here is do not round at any step. Do not round at any step, and the order of operations is important. Okay, let's go to page 6. So on page 6, we're compounding continuously in this case, so that must be the third formula, or the last formula. I think it's actually the fourth one, which is the PERT formula. This is compounding continuously. You need to use the PERT one. So we're going to deposit $1,000. That's our original principal, but we want to get 3,600, and we don't know the interest rate, but we do know it's going to be 6 years. Okay, so 6R. So we'll divide by 1,000. So we get 3.6 equals e to the 6r. So we need to get that 6r down. So we do the natural log of 3.6, natural log of e to the 6r. Okay, because the natural log cancels e, because natural log is base e. So the natural log of 3.6 equals 6r, and we'll divide by the 6. So r equals the natural log of 3.6 over 6. So r is approximately 0.2135. Thus, approximately 21.35% interest is what we want. Okay, pause the video, try the student problem. Okay, so this is compounded quarterly, so we need to use the second formula, right? So this is the one we did in the previous page. 2,000 is the final amount we're going to have. We're going to start with the principal amount of 8,000, and 1 plus the rate over 4, since it's quarterly, to the 4t, which in t in this case is 10 years. So we're going to put a 10 in for that, or just you can just simply put 40, right? Because it's quarters, 4 at 10 is 40. Okay. So we don't know the interest rate. All we know is we're losing, or we lost money. So it should be a negative answer in the end if we do this correctly. So we'll divide by the 8,000. Okay, so that gives us 1/4 equals 1. My marker won't write. 1 plus r over 4 to the 40. So do some kind of log to get that 40 down. I'll just do a natural log. That's my preference. If I do a natural log, the 40 comes down, becomes 40 times the natural log of 1 plus r over 4. So now I can divide by that 40. So it's gone. So I get the natural log of 1/4 over 40 equals the natural log of 1 plus r over 4. Okay, so the trick is now I need to get rid of the natural log on the right side, because I'm trying to get r by itself, which means get rid of the natural log, the 1, and the 4 on the right-hand side of the equation. So to get rid of the natural log, I need to do an e to both sides. So this is e to the power of both sides. This will cancel on the right side, which is what I want. So I'm going to be left with e to the power of the natural log of 1/4 over 40 equals 1 plus r over 4, because the natural log and the e cancel on the right, because I'm doing a base e to cancel that log base e, which is natural log. So now I can subtract the 1 and get e to the natural log. I didn't leave myself enough room there. Sorry. E to the natural log of 1/4 over 40 minus 1 equals r over 4. Now I can just multiply both sides by 4, but be careful to do the entire side, because it applies to the whole side of the problem, not once. The 4's cancel there. So I get 4 times e to the natural log of 1/4 or 0.25 over 40 minus 4 equals r when I distribute it. So make sure you do not round at any particular step in the calculator. So r ends up being approximately negative 0.13625. Goes on for there, hence approximately. So it's approximately negative 13.625% in the end. All right, and that is the end of part 3.